My name is Kelly Paffel. I'm technical manager for Invino Engineering LLC, a Tampa-based company. We're a domestic international engineering firm focused on steam system. Today I would like to talk about how to eliminate steam venting. We talked previously about steam venting is unacceptable in today's steam system operation. But to eliminate steam venting, we must understand the system. There are two types of steam systems. So if we were to break the systems down, there'd be two types. One, non-modulating, and the second one is modulating. Understanding the dynamics of each system will help eliminate steam venting. Of course, what we talked about before, a steam balance would be a great tool to have for any steam plant operation, which helps us to understand the non-modulating and the modulating systems and what we can do to eliminate steam venting. The first one we're going to talk about is a modulating steam system. A modulating steam and condensate process means the process application has a steam control valve. And this steam control valve here will modulate steam to the process. If the steam control valve can operate from 0, closed, to 100% fully open during operation, or anywhere in between, then we have to look at the condensate return system here. So we get proper drainage for the process or heat transfer. The modulating operating design requires condensate from the process to be recovered by a gravity 0 psig condensate system. Therefore, in this system here, P6 down here needs to operate at 0 psig, because if this valve modulates up and down and P3 has a very low pressure of 3 psi, then P4 could be very low, close to 1 psi or below. To get proper drainage, then P6 has to be at 0 psig. The condensate system in a modulating steam system will incorporate a condensate receiver. This receiver is vented to atmosphere. So this will allow the flash steam that's coming into here to be separated and vented out. Then the condensate here will be pumped away back to the boiler operation. This here system, because it's vented, it will ensure this receiver here will never be overpressurized or pressurized, thus allowing the proper condensate drainage from the process. In a modulating steam system, we do not want the steam to be vented to atmosphere. Therefore, we incorporate a vent condenser. This vent condenser is shown here in this diagram, is located right here. The vent condenser will absorb the flash steam energy, condense it down. A very simple device incorporated all the time in steam and condensate systems to prevent steam from being vented to atmosphere. As you can see, the vent condenser will consume the flash steam by heating air, water, or some other process fluid. Some fluid that we can consider to be quote-unquote the heat sink. The process fluid would consume the flash steam energy, allow the condensate to be drained back into the condensate tank. Two major benefits: flash steam is consumed and condensate is recovered. So this is the vent condenser here, operation and very easy to install, and has usually less than a year and a half payback on any system. A non-modulating system, non-modulating steam condition, means no control valve modulating the steam to the process, or a high temperature process. Outlet temperatures, typically we call temperatures above 240 degrees. This maintains a steam pressure to the process that is higher than the pressure in the condensate recovery system, if we're running a pressurized condensate system. Provides a constant differential pressure across the drain device. So, the drain device has condensate, steam control valve, or steam trap station. In a non-modulating system, in this example here, there is no modulating control valve, so there's a steady pressure put to the process here. When there's a steady pressure, we always have differential pressure here across the drain device. Then we can elevate the condensate up into a pressurized return system and send it back into the flash tank system. Examples of non-modulating steam systems: steam tracing, process temperatures with above 240 degrees, drip leg steam traps, process heater, reboilers, corrugators, etc. Those are some of the examples of non-modulating systems. Non-modulating systems, condensate and flash, can be delivered to the flash tank system. We can take the flash steam here, cascade it to a lower steam pressure, or even thermocompress it. Example would be a flash steam system or a cascade system. So the high pressure condensates come in here, which is condensate and flash. So we separate the condensate here and drain it back to a lower pressure condensate system. The flash steam is then delivered to a lower steam pressure, and that can be put into other processes. So that is called cascade, which is used all the time. There are plants that will cascade 6-7 times in their steam and condensate systems to recover the flash steam. If you have no use for the low pressure steam, then we can do thermocompressing. Thermocompressing is taking the low pressure steam and using a high pressure steam as a motive force and producing an intermediate type steam. Here's the high pressure steam coming into the thermocompressor. This is the low pressure steam, and it's a nozzle sending the steam at high velocities, and we can make a intermediate steam pressure. Very simple device. Has been in existence for many years. Another diagram of the thermocompressor system here shows the high pressure nozzle here. This is the motive steam coming into here, the low pressure flash steam coming up here, and producing the intermediate steam or higher steam pressure that can be used by other processes. Very simple device, very easy to install, and very useful to take low pressure steam and make it a more useful steam pressure. The last example I'll go through is process temperatures above 240 degrees. Because the process temperature is above 240 degrees, we will always have steam pressures that are elevated to maintain a high 240 degree or above process temperature. That will always give us differential pressure here across the drain device, and we can go into a pressurized return system, going to a flash tank, and then thermocompress it or cascade it. So today's thing is no steam being vented to atmosphere. As you can see, this plant operation here, there's no steam being vented to atmosphere. And that it concludes in-venue engineering. We're here to help, and short impact, long term. But contact us at our website or emails below.